Hey everybody, welcome back to Intermediate Algebra. Today we are in section 7.1 of our textbook, and we're going to be talking about the fundamental property of rational expressions. So what is a rational expression? Well, you know that in algebra the word rational always means that we are dealing with a fraction. So this is just algebraic expressions that are written in a fractional form. And we've got a few things to do in this section. First of all, we're going to talk about finding the numerical value of a rational expression. So they will give us a value of the variable and we will evaluate the rational expression for that given value. Then we will talk about the values of a variable that make a rational expression undefined. We'll talk about what it means for the expression to be undefined. And then finally, I'll show you how to simplify rational expressions or how to write rational expressions in lowest terms. Same thing. So that's a lot to do, so let's go ahead and get started. So first, a basic definition. A rational expression is a fraction that has a variable expression in the denominator. And rational expressions can also have variables in the numerator. And here are a few examples. Negative 6 over x to the third plus 8. This is a rational expression because it has a variable in the denominator. 9x over y plus 3. This rational expression has two variables. And 2 over 7m to the third. So this rational expression does not have a variable in the top, but it does have a variable in the denominator. Basically, all of Chapter 7 is devoted to learning how to simplify and perform operations with rational expressions, and this is a skill that you'll use over and over throughout the rest of your algebra career. First, let's talk about how to find the numerical value of a rational expression. So remember that to evaluate an expression means to find its value, and they'll have to give you a value for the variable. You'll substitute that given value into the expression and then just use order of operations to simplify. Here is an example. They're asking us to find the numerical value of 3x plus 6 over 2x minus 4. And in part A, they say x equals 1. So they want us to find the value of this expression if x equals 1. So we'll just copy the expression over, replacing the x value with the given value of 1. And then we'll use order of operations to simplify this. Now remember, when we have a fraction like this, to apply order of operations, we use the multiply and divide first, add and subtract last in the top and in the bottom separately, and then we can look at the whole fraction because it's all of this in the top divided by all of this in the bottom. So both of these values have to be evaluated separately, and then we can look at the overall fraction. Okay, first let's take care of the multiplication in both top and bottom. 3 times 1 is 3, and 2 times 1 is 2. So that's going to leave us with 3 plus 6 in the top and 2 minus 4 in the bottom. Now, addition and subtraction, in the top, addition is going to give us 9, and in the bottom, subtraction, 2 minus 4 is going to give us negative 2. So now we can look at the whole value. Now we have 9 divided by negative 2, which cannot be simplified, but we never leave a negative in the denominator. So we should either move that negative to the front of the fraction or just to the top. I usually move it to the top. So I'm going to write this as negative 9 over 2, and that cannot be simplified. And just as a reminder, another way to write this would be negative 9 over 2 with the negative in front. Both of these are fine, but to leave the negative in the bottom is not standard. Okay, let's try part B, where x equals 0. So we'll go back to our original expression, and everywhere we had x, we will substitute 0. So that's going to give us 3 times 0 plus 6 for the top, and 2 times 0 minus 4 for the bottom. Now, in both top and bottom, 0 times 3 and 0 times 2 both give us 0. So that gives us 0 plus 6 for the top, and 0 minus 4 for the bottom. So of course, 0 plus 6 is 6, 0 minus 4 is negative 4. Again, that negative needs to be moved out of the denominator, but this time notice that both of these numbers can be divided by 2, so we're responsible for doing that. 6 divided by 2 is 3, and 4 divided by 2 is 2. So that's going to leave us with negative 3 over 2. So again, I moved the negative to the top, and I simplified our fraction to 3 over 2, so negative 3 over 2. Okay, for part C, same rational expression, but this time x equals 2. So now we have 3 times 2 plus 6 over 2 times 2 minus 4. So doing the multiplication first, 3 times 2 is 6. So we have 6 plus 6, and in the bottom, 2 times 2 is 4. So we have 4 minus 4. And now when we simplify, we get 12 over 0. Now, we can't divide by 0, so 12 over 0 is going to be undefined. And now let's substitute in part D, x equals negative 2. So we'll put negative 2 in for each value of the variable. And now in the top, 3 times negative 2 is negative 6. So we have negative 6 plus 6 for the top. And in the bottom, 2 times negative 2 is negative 4. So we have negative 4 minus 4 for the bottom. Now, in the top, negative 6 plus 6 is 0. In the bottom, negative 4 minus 4 is negative 8. 0 divided by negative 8 is not undefined. 0 divided by negative 8 is just 0. 0 divided by anything is still 0. So this one simplifies to 0. Basically, if you have 0 in the top, it's 0. If you have 0 in the bottom, it's undefined. Okay, just to sum up here, for any rational expression, if the numerator equals 0 and the denominator does not, the value is 0. If the denominator equals 0, the expression is considered undefined. If the denominator equals 0, it doesn't matter what the numerator is. If the denominator equals 0, the expression is undefined. Let's talk about how to determine when a rational expression is undefined. We just saw that if the denominator equals 0, the expression is undefined. So to determine when a rational expression is undefined, we need to figure out what value of the variable makes the denominator equal 0. So we will set the denominator equal to 0 and solve. The solutions to that equation are the numbers that would make the expression undefined. And the variable cannot be allowed to equal those values that would cause the expression to be undefined. Okay, just for practice here, these are not evaluating questions. This says find the values of the variable for which the rational expression is undefined. Remember, a rational expression is undefined if its denominator equals 0. So we have to find out what value of x would cause this denominator to equal 0. So we will write 3x plus 2 equals 0. Whatever x value makes this equation true is the number that will cause this denominator to equal 0, and that means it's the number that would cause this expression to be undefined. So if 3x plus 2 equals 0, then subtracting 2 from both sides, 3x equals negative 2, and dividing both sides by 3, we find out that x equals negative 2/3. So remember, negative 2/3 is not a solution. This is not an equation to solve. Negative 2/3 is the value of x that will cause this expression to be undefined. So x would not be allowed to equal negative 2/3. For part B, remember it doesn't matter what causes the numerator to equal 0. It only matters what causes the denominator to equal 0. So here we have m squared minus 5m plus 6. We need to know what values of m would cause this denominator to equal 0. So we take that expression from the denominator and write equals 0 after it. Now this one happens to be quadratic. So we need to solve this by factoring. So we'll factor that left side, that trinomial, into two binomials. M squared is first times first, so that would have to be m times m. Last times last made a positive term. So that tells us that these signs in the binomials are going to have to be the same, and they're both going to have to match that middle term. So they both need to be minus. And then last times last is 6. So in order to get the middle term to be 5 and the last times last to be 6, I think we need 3 times 2. So I've got m minus 2 times m minus 3 equals 0. Now, we know from section 6.7 that if this times this is 0, one of the factors has to be 0. If m minus 2 is 0, then we'll get that solution, and we'll get another solution when m minus 3 equals 0. So if m minus 2 is 0, we add 2 to both sides, m equals 2. If m minus 3 equals 0, we add 3 to both sides, m equals 3. So now we can say that if m equals 2 or if m equals 3, the expression is undefined. Because if either one of those things is true, the denominator is equal to 0. That's what makes the expression undefined. Okay, let's try part C. So in part C, we need to find out what values of r would cause r squared plus 1 to equal 0. So notice that r squared plus 1 is not factorable. This is a sum of squares. Remember, sum of squares is not factorable. You can factor a difference of squares, but not a sum of squares. So this expression is prime. In other words, it can't be factored with real numbers. And that means that r squared plus 1 will never equal 0. Think about it. When you take any number, positive or negative, and square it, you're going to get a positive result. That positive number plus 1 is never going to equal 0. So there is no value of r that will make r squared plus 1 equal 0, and therefore there are no values of r that make the expression undefined. There are no values of r that make the whole expression undefined. Okay, let's talk about how to write a rational expression in lowest terms. This is exactly the same as simplifying a fraction when you don't have any variables. You simplify rational expressions the same way you simplify fractions. So an expression is in lowest terms when the numerator and denominator do not share any common factors. This is what your textbook calls the fundamental property of rational expressions. If you have p over q, and of course q couldn't be equal to 0 because then you'd have something undefined. And if k represents any polynomial, and of course k can't be equal to 0 either, then the following holds true. P times k over q times k means the k's will divide out and we're just left with p over q. Okay, basically that means that these things simplify the same way that regular fractions simplify. You just cross out any factors that are the same in the top and the bottom. And this property works because any expression divided by itself is 1. Okay, before we simplify a rational expression, let's try simplifying just a regular old fraction so we can just kind of remember how this works, and that will help you understand it when we get to some that contain variables. Okay, so we have 30 over 72. Let's factor 30 into 6 times 5, and let's factor 72 into 8 times 9. Now, I still don't see anything that can be canceled out here, so let's keep going. 6 can be broken down into 3 times 2. So 6 times 5 now becomes 2 times 3 times 5. You see how 2 times 3 is 6, so 2 times 3 times 5 is the same value as 6 times 5, and that's just 30. So I haven't changed the top. I've just changed the way it looks. In the denominator, we have 8 times 9. So let's break the 8 down into 4 times 2, and let's break the 9 down into 3 times 3. Okay, now we have everything factored. We can cancel out any factors that are the same in the top and the bottom. So I see a pair of 2's. Let's cross out our 2's. And I see a pair of 3's. So let's cross out our 3's. And notice that now we're left with a 5 in the top and a 4 times 3 in the bottom. So we have 5 in the top, and in the bottom 4 times 3 is 12. So 30 over 72 reduced to 5 over 12. Now another way to simplify 30 over 72 would have been to think of 30 as 6 times 5 and 72 as 6 times 12, and then we could have crossed out the 6's. But either way, both methods simplify to the same final reduced fraction. Now let's look at part B. So we have 14k squared over 2k to the third. Now 14 would break down into 2 times 7, and k squared we're just going to write as k times k. In the bottom, 2k to the third, the 2 can't be factored, but we will write k to the third as k times k times k. All right, now let's cancel out factors that are the same in the top and the bottom. I see a pair of 2's, so we'll cross those out. And I see one pair of k's, so we'll cross those out, and then another pair of k's. And what we're left with is just 7 in the top and k in the denominator. And that's it. So we simplified this rational expression to 7 over k. So we're about to do some that are more complicated, but just to kind of sum up what we've done, to write a rational expression in lowest terms, factor the numerator and the denominator completely, and then use the fundamental property to divide out any common factors, just like we did in that last example. So here's example 4. Write each expression in lowest terms. So basically that means cancel out the factors that are the same in both top and bottom. Now, a lot of people are going to look at the 12 and the 20 and start trying to divide both of these numbers by 2. It does not work that way because 12 is not a factor of the top. 12 is a term. It's 3x minus 12. Remember, factoring means this times this times this times this. So if it's 3x minus 12, that's not factored. So I can't work with the 12 at all right now. And the same thing for the 20. It's 5x minus 20. So 20 is not a factor of the bottom. But what we do see in the top is that there's a GCF of 3 in the numerator. 3x and 12 both have a factor of 3. So let's factor out 3 from the top. 3 times x would make that first term, and 3 times minus 4 would make that second term. Okay, now for the bottom, 5x and 20 both contain a factor of 5. So let's factor out 5. So 5 times x makes that first term, and 5 times minus 4 makes that second term. Okay, now notice that we have 3 times x minus 4 in the top, 5 times x minus 4 in the bottom. So x minus 4 is a factor of both top and bottom, so we can cross out that whole thing. And now what we're left with is just 3 over 5. So that's how we reduce rational expressions. Let's do a similar thing over here on part B. So we have 2 times y squared minus 8 over 2y plus 4. Notice that in the top, 2y squared and 8 both contain a factor of 2. So we'll factor out that 2. That's going to leave us y squared minus 4 in the top. Then in the bottom, we also have a factor of 2. So we'll have the 2 here. 2 times y makes 2y, and then 2 times 2 makes 4. So you can check that if we distribute these 2's back, we go back to the original form. That means so far so good. And let's continue factoring because now we see that we have a difference of squares here. Y squared minus 4 is a difference of squares, so that needs to be factored. I won't lose my 2, okay, I've still got the 2, but y squared minus 4 is going to factor into y minus 2 times y plus 2. Because remember, when you have a difference of squares, it factors into square root minus square root times square root plus square root. And then we still have 2 times y plus 2 in the bottom. And now let's see what we can cancel out. So notice that we have y plus 2 in the top and in the bottom, so those can go. And we also have factors of 2 in both top and bottom. And all we're left with here is just a y minus 2 in the top and nothing in the bottom, but that doesn't mean that it's over 0. Remember, there's always a hidden factor of 1 that's not written. And, anytime we have a whole number or anything, the denominator is always understood to be 1, and that's the same thing here. The denominator is 1, but because it's just 1, we don't have to write it. So this would be written as just y minus 2 in simplest terms. Okay, continuing with example 4. Here we have m squared plus 2m minus 8 over 2m squared minus m minus 6. So we'll go ahead and factor both of these because looking at the top, I do not see a GCF, and looking at the bottom, I do not see a GCF for that either. So both of these trinomials are going to factor into 2 binomials each. In the top, m squared is going to break down into m times m. The last term is negative, so that tells me that these signs in the binomials have to be different. So I just put a minus and a plus, and then last times last made 8. So, of course, the first thing that comes to mind is 2 times 4. I think in order to get the middle term that we want, we should put the 4 with the plus and the 2 with the minus. And that way you can check that outer plus inner adds up to positive 2m for the middle. Okay, now let's look at the bottom. I cannot factor out that front 2 because it's not a GCF because the middle term is not divisible by 2. So we just have to keep it, but that's okay. 2m squared can be broken down into 2m times 1m. So we'll put those in place. Last times last made a negative number, so that tells me I need different signs here. Now should the plus go here or here? I don't know right now, but I'm going to guess that the minus goes here and the plus goes here. It's just a guess at this point. Okay, for the 6, of course, we're thinking either 2 times 3 or 6 times 1. Let's try putting the 3 here and the 2 here. And let's see what we get for our middle term. Outer times outer is 4m. Inner times inner is negative 3m. Now 4m minus 3m is going to add up to positive 1m, but I need it to add up to negative 1m. So that tells me that my signs here are backwards. So I'm just going to erase and switch the signs, and let's try it again. Outer times outer is negative 4m now. Inner times inner is positive 3m. Negative 4m plus 3m adds up to negative 1m, and that's what we wanted. And so now we're sure that the factoring is correct in the bottom, and now we can cancel out like factors. So notice that we have an m minus 2 in both the top and the bottom, and the other two we can't do anything about. So we're going to end up with an m plus 4 in the top and a 2m plus 3 in the bottom. And that's it. Now remember, you cannot cancel from terms. So this m that's a term in the top cannot be used to cancel this m in the bottom because these are not factors, they are terms. Okay, for part D, it looks like we have 4 terms in the top and 4 terms in the bottom. And so we'll have to use the factor by grouping method to get these factored. So remember, when we factor by grouping, we factor a GCF from the first 2 terms, a GCF from the last 2 terms, and then if they have a common binomial, we factor out the common binomial. So we'll do that for both top and bottom. Here we go. In the top, 4m plus 12 has a GCF of 4. So let's factor out that 4. That will leave us with 4 times m plus 3. The second group starts with a negative. So we'll have to factor out a negative p. Notice that they both have a p. So the p is the common factor, but we need to factor out a negative p because of this existing minus sign right here. So when we factor out negative p times m would make this first term, and negative p times positive 3 would make this second term. All right, so check it. Negative p times 3 makes negative 3p. We had to change this sign to account for this negative because we already had a negative here. Now let's go ahead and get the bottom worked that far. So in the bottom we have 5m plus mp. The m is the common factor, so we'll factor out a GCF of m. And in the parentheses we're going to have 5 plus p. The second group starts with a plus, so we don't have the same problem we had in the top. But we do see a GCF here of 3, so let's factor out a 3. That's going to leave us with 5 plus p. Okay, now notice that in the top, both groups have a factor of m plus 3. So we'll factor out the m plus 3, and that's going to leave us with 4 minus p as our other binomial. In the bottom, we'll factor out 5 plus p, and that's going to leave us with m plus 3 as our other binomial. Okay, now what's common to both the top and the bottom? Well, they both have a factor of m plus 3, so we cancel those out, and that leaves us with 4 minus p over 5 plus p. And again, I'm just going to point out one more time because there'll still be somebody who is not thinking about this right. The p's cannot cancel out. Why not? The p's cannot cancel out because these p's are not factors. It's 4 minus p, not 4 times p. So this p is not a factor of the top, and therefore it cannot be used for simplifying. And this is it. This is our simplest form. Okay, I know I'm beating this drum pretty hard here, but I really need to drive this home to you because this is one of the biggest mistakes people make when they're trying to simplify rational expressions, is they try to cancel out terms. And you cannot cancel terms. Terms cannot be canceled. So here's an example of what you can't do. If we had 6x plus 10 over 7x plus 5, a lot of students think you can cancel out the x's and that 10 over 5 will reduce to 2 over 1. That is false. So a lot of people would do this and they would end up with 6 plus 2 over 7 and they would get 8 over 7 as their answer. That is completely wrong. You cannot do that. In fact, the expression we started with can't be simplified at all. So this would be 100% wrong. All right, let's keep going here. Let's see what else we have. When you're working with a difference, you can change the order of the difference by factoring out a -1. And this is a really useful trick, especially for later on. So if we have y minus x, what we can do is factor out a -1, which that would make us have -y plus x. Okay, we don't usually have to factor out -1 when we're factoring like a trinomial or a binomial, but suppose that you had y minus x, but you wanted to be able to turn it around where it's x minus y. You can do that by factoring out a -1, and then of course you have this difference inside your parentheses, and that can be written in the other order. -y plus x can be written as x minus y, because you see the x is positive and the y is negative. And of course the -1 can be written as just minus. So see how factoring out a negative allowed us to change the order of the subtraction. Instead of y minus x, now it's x minus y, but we have this front negative. So these two are equivalent, and this is a pretty useful trick. So let's try that with this example right here. So we have x minus y over y minus x, and it says write it in lowest terms. So we cannot cancel right now because these factors are not alike. The top and the bottom are different. But what we can do is change the order of subtraction in the top by factoring out a -1. So that's what we saw in the last slide. I can change this to y minus x if I factor out a -1. So we're just going to do that directly. If I factor a -1 out from the top, that's going to make -x and positive y, which I would write in the opposite order. So I would put y minus x. So basically, bottom line, if you factor a -1 out, it changes the order of the subtraction, and you don't have to go through all the middle steps. The bottom will leave the same. We don't want to do them both because we're trying to make them the same. If we change them both, they'll still be different. So now I've got -1 times y minus x in the top, and I have y minus x in the bottom, and I can cancel those, and that just leaves us with -1. See how neat that is? It just makes it so simple. If you need to change the order of subtraction, you can just factor a -1 out from that subtraction. Okay, let's try again here. So it says write each rational expression in lowest terms. So here in part A, we have 2 minus m over m minus 2. And we're going to do the same thing we did in the last slide. We're going to change the order of subtraction in the top by factoring a -1 out from the top. So the top will become -1 times m minus 2, and the bottom will stay the same. That way we can cancel out m minus 2's, and we end up with just this -1 right here. Okay, let's try in part B. We have 4x squared minus 9 all over 6 minus 4x. Notice that 4x squared minus 9 is a difference of squares. So that can be factored as 2x minus 3 times 2x plus 3. In the bottom, we do not have a difference of squares, but we do have a GCF of 2. Notice that both of these numbers are multiples of 2. So if we factor out the 2, or in other words, undistribute the 2, we would then have 3 minus 2x in the parentheses. Okay, now when you get ready to cross things out, you notice that we really can't quite cross anything out yet because we don't have any like factors. We have some that are opposites. We have 2x minus 3 in the top and 3 minus 2x in the bottom. So they're very closely related, but they're not exactly the same. What we want to do is change the order of one of these subtractions so that they'll be the same so that we can cancel them out. Now, honestly, you could change either order. It doesn't matter which one you change, but we know that if we end up with a negative in the bottom, we're going to have to move it anyway. So I say let's change the order of the top one so that the negative will be in the top. And so that's going to make this top become negative 1 times 3 minus 2x, and then this stays the same. In the bottom, we'll still have 2 times 3 minus 2x. And now we have 3 minus 2x in both top and bottom. Those can be canceled, and we're left with negative 1 times 2x plus 3 all over 2. Some people are going to say you should distribute the negative 1, but it's not required. It is not necessary. It's not wrong if you do it, but it's just not necessary, so I'm not going to do it here. Now for part C, 3 plus r over 3 minus r. Could we factor a negative from this denominator and turn it around so that it's negative 1 times r minus 3? Yes, we could. But would that help us reduce anything? No, it would not, because the top is not the opposite of the bottom. The top is not a subtraction where the bottom is. So changing the order of this subtraction doesn't help. So here we're just going to say that 3 plus r and 3 minus r are not opposites, and therefore this fraction is already in lowest terms. It cannot be reduced at all. And that's it for simplifying rational expressions. We're going to keep needing to use this skill throughout the rest of Chapter 7, so I hope you'll really work on this, work on your factoring, work on your simplifying, so that the rest of Chapter 7 will go smoothly for you, and I'll see you again in the next section.